Alright, today's video is on graphing inequalities, and before we talk about graphing inequalities, we're going to review real quick what it means to graph equations. Very simple concept, won't be difficult to get at all. This obviously is a standard number line going from -4 to +4 by ones. So let's look at what it would look like if we were going to graph some very simple equations on here. For example, x equals 3. If we're going to graph x equals 3, all we would have to do is find +3 up here on the number line, put a dot, and there we go, we're done. We've just graphed on this number line x equals 3. If we were going to graph x equals -2, for example, we would put a dot up here on -2 to represent that. I guess let me switch colors here. And if we were going to do x equals 0, we'd put a dot on 0. All right? Very simple, easy stuff. You've been doing this for years, okay? So we're going to be doing the exact same thing, only instead of equations, which is what we have here, we're going to be graphing inequalities. Okay, so let's go ahead and look at how this works. All right, here we've got, let's start with the inequality on the far left here. X is greater than or equal to 2. Okay, well, just like if it were an equation, the first thing we need to do is find +2 on our number line. Here it is, +2. We're going to put our dot on +2. And now let's think to ourselves, what does this inequality mean? It means x is greater than or equal to 2. X is any number in the world that's greater than or equal to 2. Well, here's the number that's equal to 2. But we've got to represent that the answer is also all the numbers that are greater than 2. Well, our graph only goes to 4. But remember, these number lines always they really go to positive and negative infinity, right? Okay, and we need it to go to positive infinity in order to graph this answer. If x is all the numbers that are greater than or equal to 2, here's the equal than, and to show the numbers that are greater, we're going to start drawing a line that goes through all the numbers greater than 2. So there it goes through 3, there it goes through 4. We've hit the end of our number line, so we're just going to draw an arrow here to show that this solution would go on forever and ever in the positive direction. It's going to hit 3, 4, it would hit 5, 6, 7, 8, 9, 100, 500, 5,000, etc., etc. It would hit all those numbers because all of them are greater than or equal to 2. So there's our answer for x is greater than or equal to 2. All right? Let's look at the next one. X is less than -1. All right? X is less than -1. Well, again, first we're going to find -1. -1's right here. Now there's one small difference on this one. Notice that it could have been equal to. X was equal to 2 or greater. And notice that when we did that, we filled in a regular dot on 2, just like normal. This one's slightly different because x is less than -1. That means if we put -1 in for x, -1 is less than -1. Would that make it true? No, that actually makes it false because -1 is not less than -1. It's exactly equal to. So what that means is -1 is actually not part of our solution to this problem. Okay, -1 doesn't work. But we still have to start on -1. So what are we going to do? What we do is we put a dot here, but we leave it open. It is not filled in. It's an open dot. That shows us that even though we start at -1, the actual number -1 is not part of the solution. It's not part of it. Okay? But what is part of it? X is less than -1, so all the numbers that are less than -1 are going to work. So our arrow starts to come out from this dot, this time hitting all the numbers that are less than, and we draw an arrow. -2 works, -3, -4, and so on all the way down to -infinity. You might say, Mr. Reed, why can't we just start at -2 and do like a closed dot there? Well, then we would be excluding all of these middle numbers. Like, for example, -1.5 is right here. That works. That's part of our answer. If we started our dot here, we wouldn't have included -1.5 or any of those other numbers between -1 and -2. So you still have to start on -1, but it has to be an open dot. All right. Let's look at our last example here. 6 is greater than x. 6 is greater than x. Well, first of all, whoops, our number line doesn't go this far. Let me extend the number line for a second. Here's 5. Here's 6. Okay. 6 is greater than x. Well, the number we start on is 6. Let's just go ahead and draw an open dot for now. Because this is greater than and not greater than or equal to, it's going to stay an open dot, right? Because if we put in the number 6 here, 6 is greater than 6. Is that true? No, it's not. So 6 is not part of our answer. Therefore, we have to leave it as an open dot. All right. Now this one, notice, is flipped compared to the others. X was on the left here, X was on the left here. This time X is on the right. We got to think about how it's going to affect our answer. Look at what this is saying. 6 is greater than all of the answers that make it true. 6 is bigger than all the answers that make it true. Therefore, all the answers that make it true are less than 6. Okay? So, judging from that, our arrow has to be hitting all the numbers that are less than 6. And we're going to go to here, draw an arrow to show that it goes on forever and ever. If you're not sure, an easy way to check is just pick a number and see if that makes it true or not. So let's pick the number 1. What if we put 1 in here? 6 is greater than 1. Is that true? Yes, it is. Therefore, our arrow should be on this side. What if we had picked 10, or any number that would be to the right of this number line? If we had picked 10, 6 is greater than 10. That's false. Therefore, all the numbers on the right side do not work. That helps us figure out which way the arrows go. All right, that's pretty much the whole concept. Make sure you answer the question in the description, and I will see you tomorrow in class.